numbers you want to see, do go over, have questions about? I'm seeing majority 1 and 2, and then I saw a 3 or a 4, so I'll let you guys choose, put up a 3 or a 4. I think there are more 4s, just by a couple. So we'll do 1, 2, and 4. Most, if not all of these, can be done in Desmos. So starting with number 1, we have to find the line of best fit by making a table with the numbers in that table. So I can see all of my data, and then if I type in y1, the squiggly line, the tilde, mx1 plus b, we'll get our slope and y-intercept, and we would write that together in our line of best fit. So y equals 0.891, let's just do 3 decimal places, 0.891 x minus 0.086, or 0.807 for rounding purposes. So that would be your line of best fit to answer number 1. For number 2, it says using number 1, find the milk consumption in a 1 week of a 7-member family. So if we put x equals 7, and found where those 2 lines cross, that would be our answer to number 2, 6.1. Let's, because all of these are 1 decimal place, let's say 6.2. Gallons of milk. Make sure you use Desmos if you just wrote that down, or you use Desmos to find that answer. Number 4 is similar to one we did on the last chart, right? You can use the graph if you solve it, but because it's not in slope intercept form, I'm just going to use Desmos for everything. So I'm going to put in the point, -4, 0. Put in the equation given, x minus 2y equals 14. I'm going to find the slope of this line. If it's parallel, the slope has to be the same. So from this point, it looks like I'm going up 1 to the right 2. So that would be my slope. And then I'm going to type in my y equals mx plus b. Add in all my sliders. Change my slope to the slope I just found, 1/2. And then move my b until it goes through that point. and that was at -2. So the equation would be y equals 1/2, y equals 1/2 x minus 2. And you could say you use Desmos to get full credit for that. If you were doing this algebraically, you would have to solve the equation and then use your point slope form, or you could use your graph. Questions there? Look at your course calendar. There are a bunch of things on it, a bunch of things we have to talk about. So one, this is everything we're doing for the rest of the year. There are 4 units worth of information here. Delta maths, which ones are formative, which ones are informative. All of Unit 9 Delta maths are formative, and then 10, 11, and 12 Delta maths will go back to being informative. Nothing else changes except it will be formative. I mentioned last class that the next SOL practice that's due, 6A and 6B, are informative still, but the 2 after that, those will be formative grades. It does not have your JLab date up here, but your SOL date is May 15th. I wouldn't see you guys that day anyway, but the next day, May 16th, is when I would see you guys, so that is when your JLabs are due. You want to write that onto your calendar if you use it. It has your SOL date. It has your final exam date for those of you that need to take it. It also has our test date. Previously, I had sent out an email saying that we were going to test all 4 units, and then I would drop the lowest 5 objectives. But time-wise, we don't have time to take all 4 unit tests, so we're just going to take 2 of them, and I'm going to drop the lowest objective. So just 1 objective will get dropped, and I'm going to resend out an email to say that. I think that's the gist of everything. What questions do we have on upcoming units, upcoming assignments, dates, SOL, anything like that? Yes.
So do we have to take the final exam?
So that depends on your SOL score. If you pass the SOL, you're exempt from taking the final. If you pass the SOL and pass advanced, you get 100 put in for your final exam score, and that would change your grade. If you don't pass the SOL, but fall within the expedited retake score, 375 to 399, and retake it and pass, then you'd still be exempt. If you don't pass the retake or don't fall within that score, you would have to take the final. Then you could also opt in to take the final if you pass the SOL, if you wanted to better your grade. Other questions? If you think of other questions, please ask. We are going to start our notes for today, so you should have that. I'm going to start on the first page. So this unit is all about factoring. A lot of what we did with our exponent rules and polynomials will come into play here. So we can't lose that information because we'll need it here. So we're going to try these warm-up problems first, where we are distributing, so multiplying. And if we are multiplying like bases, we're adding the exponents. So if I multiply the a to both of these, what would be left? And we can say these out loud. 3a squared. And then a times 7 plus 7. And then do the same thing for the next part. Multiply negative 2m to everything here. Negative 2m times m squared. Bless you. Bless both of you. What would that be? Negative 2m times m squared. Negative 2m cubed, 4 to the third. Negative 2m times 6m. Negative 12m squared. And then negative 2m times negative 1. Positive 2m. The last one we're going to go a little slower, but multiply this entire term to x squared and to 2y. What would that give us? Or x to the fifth power y minus 8x cubed y squared. Okay. So today we're going to be doing the opposite. We're going to be given a bunch of problems that look like this and convert it back to this. That's what our factoring method is. So I'm going to have you guys write down some definitions. You can write down this, all of this part. So when we factor, we are separating a polynomial, the umbrella term, all of the different kinds, back into a product. I'm going to explain how we do that with this problem here. So when we factor, and today we're going to start factoring by GCF, greatest common factor, we are looking for the highest number we can divide out of all the terms. So if you know that off the top of your head, great. If you need to list them out, that's also fine. So if I were to list out all the factors of 4, what times what gives us 4? 2 times 2, and 1 times 4. And then let's do the same thing for 8. What times what will give us 8? 4 times 2, and 1 times 8. And then of those, we're looking for what is the highest number they both share? 4. So that would be the greatest common factor between the two of them. And when we factor, we're going to divide by whatever that GCF is. But when we divide here, we don't want to get rid of things. So when we rewrite it, we're going to put it actually out front. And then we also have to look at variables. If they both have the same variable, we have to look at the lowest exponent. Because I couldn't take 2 a's out of this, you get a negative exponent, and we're trying to avoid that here. So I could take at least 1 a out of both of these. And then your dividing exponent rules come into play. So if I divide both of these by 4a, 4a squared divided by 4a is what? Just a. We're subtracting the exponents. And then 8a divided by 4a is what? 2. So whatever is left when we divide is on the inside of the parentheses. Whatever we divided by is on the outside. And then on the inside, we want this to be prime. So prime has 2 definitions. One is factors of a number are itself and 1, that is a prime number. And then these are prime factors if nothing else can be done here. If we can't divide out anything else. So we want our inside answers to be prime. Questions so far? So now we're going to get into some actual factoring pieces. Some of these you'll be able to see the numbers right away. Some of them you may want to write out the factors of whatever the number is. If you get stuck, go back and do the steps. Find the GCF, the highest number you can divide out of both. Look at the coefficients first. Then look at the variables, look at the lowest exponent. Divide both terms by the GCF, see what's left, put that inside in parentheses. We can double check ourselves by distributing. I didn't do that this time, but if I were to distribute this back out, 4a times a is 4a squared, 4a times 2 is 8a. So that works. Sometimes the smallest number you see is the GCF, but not always. What is the number I can divide out of both of these?
3.
So if I divide these both by 3, I'm going to put that 3 on the outside, divide each term, and see what's left. So 3x divided by 3 is plus 4. And if I were to distribute that back out, 3 times x is 3x, 3 times 4 is 12. So that works. What about number 2? What can I divide out of both of those? 7. Once you get the hang of this, you don't have to keep writing that you're dividing. You could skip right to this step, but for now we'll do this. So if we divide both by 7, what would be left?
Y.
At the end, y and then minus 1. Yes. And if I distribute that back, 7y minus 1. Do we know off the top of our heads what is the highest number these two share? Factor these two share?
4.
It is 4. If, let's say we forgot about 4, and we know they're both even, and I divide it by 2, I'm just going to show you what happens if you don't choose the highest. So let's say I know these are even, I can divide them by 2, and I go ahead and I do that. Well, because I didn't divide by the highest GCF, I see that this is not prime. I could divide this by what? 2. I could divide something else out of it, which means it's not prime. But I can still do that. Divide these both by 2. Whatever I divide by comes on the outside. So there's a 2 already there. This 2 also gets put on the outside. And then I would just multiply those 2's together. But if we had divided everything by 4 from the jump, then we'd end up with this. So whether you do that at the beginning or the end, it doesn't matter as long as you eventually factor out the highest. Questions there? Go on to the back. Okay, let's look at 6. What is the highest number we can divide out of both of those? What did you say? 4. And then do they have anything else in common? The variable. How many y's could we divide out of both? Just 1. Because this one doesn't have 2, I couldn't take 2. I couldn't take 2 out of 1. Yeah. So I'm going to divide both by 4y. I'm going to stop writing that I'm dividing, but if you want to keep doing that, keep doing that. If I divide both of these by 4y, what's left? Y minus 6. And if I were to distribute that back, we get 4y squared minus 24y. Let's do 7. The highest number we can divide out of both of those. 3. And then do they have anything else in common? D. So divide both by 3b. What's left?
C-1.
7c minus 1. Questions so far? You are confused or not understanding? This is your time to ask. Let's do 9. What do those have in common? Highest number that those have in common? 15. Do they have anything else in common? A and
B.
1a and 1b, so divide both by 15ab. You're subtracting your exponents when you're dividing. What's left? A minus 2. Plus, let's do 12. What do those have in common?
They both have X.
They both have one x and one y, so divide that out. What's left? X plus 3. Again, the more variables you get, you may want to divide each piece. Write that you're dividing each piece so you can see it, but if you can do it without it, that's also fine. For number 13, what could we divide out of that? Is there anything? 1, but that's it. And because 1 is the only thing we can divide out, this is prime. It's already in its simplest form. We can't factor it more. Now, when we get into more factoring methods, sometimes you will have to use a different method, but that doesn't mean it's prime. But this one is. Alright, 14. What is the highest number these both share? And if you need to list out all the factors of 18, all the factors of 48, do that. Six. And then, do they have variables in common, and how many of each? Say that one more time. 1a, 1b, only 1b? 2 c's. So lowest exponent. And then we're going to divide each of those terms by 6abc squared. Take that one step at a time. It's very easy to lose variables or miss an exponent if you're going too fast here. Two a minus what was the rest of that? 8c. 3a.
Yeah.
Oh, here. Okay, let's look at 16. What's the highest number we can divide out of each of those? Three. And then, do they have any variables in common, and how many of each? There's one R. What about S's? Do they each have an S? No. So that was a trick question. So you can't use S because they each don't have an S. But 3R would work. Divide each piece by 3R. What's left? r to the power of 7 minus 6rs minus 8s squared. So this looks like we should do more with it, but if we really look at it, only 2 of these things can be divided by 3. Only 2 of these things can be divided by 2. Only 2 of them have r's, and only 2 of them have s's. So this is prime. There's nothing we could divide out of each piece. So that is our final answer. Do you have any questions so far? Let's do 20, and then I'll let you guys choose any others. What's the highest number we can divide out of each? If you need to list out the factors of 18, 24, and 36, do that. 6 works. And then what variables do they have in common, and how many of each? One Z. They don't all have X's and they don't all have Y's. So just 6Z. And then what would be left if we divide each one by 6Z? What squared? X squared y minus 4xz plus 6yz squared. Again, it looks like it's not prime, but if you look at it, there's nothing we could divide out of everything. Are there any that we skipped over or any remain that we want to see, do, go over, have questions about?
21.
21. Any others?
24.
24. Okay. Right, for 21, what do those have in common? What's that GCF? 1m and 1n. Divide each piece by mn. M squared minus mn plus 5n squared. Okay, and the last one, what would that GCF be? 3. What variables, how many of each? One A. Okay, B squared and 1C. I'm just rewriting it like this, so you take it one step at a time, look at all the numbers, subtract all the exponents. 3a cubed b squared c divided by 3ab squared c would be a squared b minus, what would this middle term be? 3ab squared c, and then the last term,
5b cubed c2
plus 5b squared c squared. It's really hard to see at the end, but those should be squared. GCF of all the factoring methods is probably the second easiest. It could be interchanged with second and third. I'm going to show you the first next. If you want to take a second, stretch, get out of your seat for a second, you can do that. And then when you're ready, go on to the next page. Okay, like the GCF, we're going to try these warm-up problems first. We have binomials being multiplied to binomials, so we're going to multiply FOIL, double distributive, box method, however you want to do that. I'm just going to use FOIL. X times X would give us X squared. X times negative 4, negative 4X. 4 times X, plus 4X. And then 4 times negative 4, negative 16. When we combine like terms, what happens? The x's cancel, leaving us with x squared minus 16. Let's do the next one. 5m times 5m. 25m squared. 5m times negative 1. Negative 5m. 1 times 5m. Positive 5m, and then 1 times negative 1. Negative 1. When we combine our like terms, what is our final product? 25m squared minus 1. And then do the last one. 2a times 2a, 4a squared. 2a times negative 3b, negative 6ab, 3b times 2a, positive 6ab, and then 3b times negative 3b, negative 9b squared. And when we combine our like terms, what would the final result be?
4a squared minus 9b.
So we're going to be given a bunch of these difference of squares. We're subtracting, and each term is a perfect square in some way, shape, or form. And we're going to have to convert it back to this. So how we do that, one, make sure that we're actually subtracting, because it doesn't work if we're adding. And then if it's in that format, we're going to have two sets of factors. And you're going to be thinking, what times what would give you a squared? A times a. So you're going to put that a in both sets of factors first. Ignore the negative for a second. What times what would give us b squared? B times b. So put that second in both sets of parentheses. And then one of your factors needs a plus, the other one needs a minus. And then you can check your work by distributing FOIL method, box method, any of those. So if I did a times a, that would give us a squared. A times negative b is negative ab. B times a is positive ab. And b times negative b is negative b squared. And then those would cancel. So you could always distribute to check your answer. You don't have to do that. It's not a necessary step, but you can. So we're going to be rewriting these into this format. So in number 1, we are subtracting. We have perfect square terms. We found that a times a would give us a squared, so I'm just going to rewrite that part. What times what would give us 4? 2 times 2. And then put a plus, put a minus. It does not matter if the plus comes first or the minus comes first. You just need one in both. Questions on how that works? So then in number 2, what times what gives us n squared? N times n. What times what gives us 64?
6 times 6.
Not 6. Close? Easy. And then put a plus and put a minus. If your order is switched, you have to put your factors in whatever order the order is given. So if it's a number first, your number has to come first. If it's a variable first, your variable has to come first. So how would I write these factors? 9 plus x and 9 minus x. And those would be our answers. Questions so far? Can we do number 5? Is number 5 a difference of squares? No. So because it's adding, we don't know how to factor something with adding like this. It doesn't have a GCF. We can't use difference of squares, so this is prime. So they may throw some of those in there to confuse you, and then you go ahead and do the k minus 5, k plus 5, but that wouldn't give you k squared plus 25, so be careful there. What would 7 be? What would those factors be? 3b minus 10 and
3b plus 10.
yes. What about 12? What would those factors be?
8u
8u
minus
minus b and
8u plus b.
8u plus b. If you have u's and b's together, make sure your u's and b's look like u's and b's. Are there any others here that we want to see, do go over, have questions on before we go to the back? Turn over to the back. Now this top part, these are a little bit more challenging because you may see more variables together or higher exponents. As long as the exponent is even, you just divide that by 2. And then everything else works the same. So for 13, what would those two factors be?
xy minus 1.
xy minus 1
xy plus 1.
and xy plus 1. If you're not sure what times what goes into a number, take the square root of that number, because all of these should be perfect squares. This should be 25 for number 15. For number 16, how would we write those two factors? 7m squared minus 4 and
7m squared plus 4.
okay. Number 17, how would we write that one? K to the third minus 4 and k to the third plus 4. Correct. Are there any others in that section, that top section, that we want to see, do, go over, have questions about before we talk about the bottom? 20, okay.
Eight n squared
Minus
minus 3 n
3n, and then the other one?
8n squared plus 3n.
Other questions there? Okay. In the bottom section, when you have two terms, one of three things can happen. You could have just a GCF, you could have just difference of squares, or you could have a combination of both. Always check for a GCF first, because that'll tell you if you need to look at a different method. So I'm going to show you how to do this in the calculator also. Doing it in Desmos is very similar. We could look at this and see that 2 is going to be our GCF, but for later when you get higher numbers, in your calculator, go into math, scroll over to number, and go down to number 9. It says GCD, which is greatest common divisor. You're dividing out the greatest common factor. It's similar. So math, scroll over to number, go down to number 9. Your calculator can only do 2 numbers at a time, but you can put in 2,72, hit enter, and it will tell you what that GCF, GCD is. So I know that I can divide both of these by 2, leaving us with n squared minus 36. Then you have to look at, could I do anything else with this? Could I factor out another GCF, or could I use the method I just learned, difference of squares? Here, this is difference of squares. So I would separate that into 2 factors. What would those 2 factors be? And minus 6 and n plus 6. So when you have a GCF and difference of squares, you're going to have both pieces. The 2 factors from difference of squares and the GCF on the outside. You have to factor these completely, otherwise they're not simplified. Questions there? Let's do some of these other ones. Look and see, does this have a GCF? 32 and 18. Does that one have a GCF? 2. So we could divide them both by 2. What would be left?
S squared.
What number here? 16s squared minus 9 squared. Could we use GCF or difference of squares here? Yes, which one? Difference of squares. So then what would those 2 factors be? 4s minus 3u and 4s plus 3u. We'll do one more and then any of you guys want to see you go over. In number 24, what would that GCF be? Or does it have a GCF? Like you said. 5. And because these exponents have odd powers, there has to be a variable included with that. So 5q. If I divide out 5q, what's left? 9q squared minus 4. And then could we use GCF or difference of squares here?
Difference of squares.
Yes, and then what would those 2 factors be? 3q minus 2 and 3q plus 2. Are there any others, 25 through 32, we want to see, do, go over, have questions about? I'm going to make up a random example just to show you something that you might see. If you got something like 81x to the 4th minus 16. This is a difference of squares problem. It doesn't have a GCF. So we could do difference of squares. What would those two factors be? We broke that down into two factors for difference of squares. What would that be? So if you got something like this, we broke that down into our two factors. However, when we did that, we created another set of difference of squares because this is all perfect squares. So you have to break it down again. You would just bring this one down because we can't do anything with that. It doesn't have a GCF. We can't use difference of squares. And then this one would have two other factors. What would those two factors be?
3x plus 2, 3x.
So you have to break it down as far as you can as possible, and then once you can't do anything else, then everything is prime. That would be your final answer. Questions on that? For the remainder of class, you could be working on one of the following things. Your SOL practice for when we get back, practice in these notes. Your Delta Math, remember that is formative, that is due on Friday. Your JLabs, be working on any of those things. Let me know if you have questions.